Welcome back to ITP 115, Programming in Python. This is video 3 of 3 for week 6, and we're going to be introducing a new type of variable today called lists. Recall, we were talking about the indexing and slicing of sequences, right? Strings start at index 0 and go up to the length or the number of items in a given sequence or string minus 1. Also recall that a string is what we say immutable, not mutatable, unchangeable. We cannot modify or change a single item within that string. And this was the example that we looked at last time, right? Do not confuse immutable with what we call const or final or constant, right? We can change the overall value, right? We can do this. This is called reassignment, right? But really, this is actually two different strings. We're actually creating two different strings here. This is valid, right? This would compile. All of this would compile or interpret and run. This would work, no problem. But if we try to change just one part, reassign just one item, right? Random or item assignment, this would fail because we cannot mutate. We are not able, right? Immutatable, immutable, not changeable, right? We can't change a string, right? Well, that's frustrating. Is there a type of sequence that we can mutate that is changeable? Yeah, there is, and it's called a list. It's a new type of variable. It's called a list. Here's the motivation for why we would want to have a sequence type like a list. Suppose that we were reading in test scores from a user, and we stored their first input as test score 1. We learned on the previous video how to validate that this is a integer that can be successfully typecast into an int, and we store it as test score 1. And then finally, at the end of it, we sum up all of these test scores together and divide the sum by the count and display an average, right? Okay, we could maybe do this with 3 variables, right? No problem, we could do that. But what happens if we had 6? What about 10? What about 100? What about 600, right? Then that's a lot of variables to keep track of. What if we wanted to keep all of the test scores together and be able to revisit and look at all of them and do more advanced analytics on the collection of data, right? So we could do that, right? We could put everything in a variable. That's impractical. If we wanted to do more than just a few, it would be hard to loop over that. We learned about while loops and for loops already, and then we might get mixed up. We might make a copy paste error. We might call test score 2 instead of 3, right? Really, what we want is a type of variable that can store a sequence that is mutatable, that is mutable, called lists. So lists, right? So this is a new type of variable. Just like we've been talking about ints, the types that we know so far are ints, floats, and strings. And we learned about the things that we can do with them. Now we're introducing a new type of variable called lists. Lists are sequences, just like strings, okay? They are mutable, mutatable, changeable. We can do item assignment, right, is what that means. And instead of, right, a string is very specific. It's really a sequence of characters. But a list can be a sequence of anything. It could be a sequence of characters. You could represent a string as a list, but it could also be a sequence of numbers, like our test scores. There's a note down here that says Python allows you to have lists of different types, but many other languages don't allow that. So for this class, we're going to assume that all of the types of things within a given list will all be the same. So lists in this class will either be all numbers, all characters, etc. All ints, all floats, or all strings. Okay, here's the syntax for it, right? The giveaway that we're dealing with a list now is these starting square brackets, right? So the square brackets define a list. They're comma separated, and we can just put in a sequence of any type of type, right? Ints, floats, and strings are what we know so far, right? Ints, floats, and strings, okay? Remember that strings can have spaces in it, right? So it could be a list of sentences, right? It could be a list of numbers, right? Or any other type of variable that we could cover in this class. So lists are sequences, just like a string was a sequence of characters. You can think of lists as kind of like an abstract sequence of anything, right? A list of items, okay? So here's some examples. Suppose we had a variable of type list called things. We know it's of type list because it has these square brackets here. Then it's strings because of the double quotes. So this double quote lines up with that double quote. This square bracket lines up with that square bracket, and each individual string is separated by a comma. Okay, so and then this is what it would look like. Kinda, you can think of it as things, as you know, the values down here. And remember, they're sequences, so they each have indices. And then we could have another list, in this case called stuff, that has dog, cat, boa, and it would look like this. Okay. We can do concatenation, or basically joining or merging. Right? Remember, we can write things plus equal, which expands out to old things plus stuff is now equal to new things. That's how we would read that. So things now is equal to what things was plus this additional stuff, right? And so this is what things was before here, and we add stuff on to the end of it, like this. Then we would end up with new things that looks like this, okay? So that's string concatenation. We can also use the index operator, the at or address operator. So we can say, right, if things and stuff still looks the same as before, we can now make a new variable, okay? And we can say, the way we read this is animal equals stuff at index 0. So then we would go to stuff, look up index 0. What's the value there? Well, it's a string called dog. So this would resolve or return a string called dog, which would now get stored into, right? Right? Animal. So now animal is a variable of type string. These are very common questions, right? We want to make sure that you guys understand that these are lists of strings, so a single item of a list of strings would be a string. And these are right, the question 2 and question 3 are two ways of asking for the same thing, right? Stuff at index 0 is that, right? That's stuff at index 0, that's a string. Then because we're setting animal equal to that, it's also a string. What is stuff? Well, stuff is a list of strings, so a single item in a list of strings is a string, and then a variable that we set it to would also be a string. All right, suppose that we had a slice of a list of strings, right? So stuff is saying start at that, stuff is a list of strings starting at index 0. We would get dog and cat up to but not including index 2, so it's just dog, cat. It looks like that. And so now we are left with also a list of strings, okay? And so as a rule, you can say that a slice of a list of strings would also be a list of strings, even if that list is only one item long, 0, 1, or more items long, right? A slice of a list of a certain type will always be a list of that same type, all right? So, for example, a slice of a list of strings will always be a list of strings, 0, 1, or more items long. We can, just like with strings, we can call the function len, or short for length, to get the length of a given list. So 1, 2, 3. So the length of the list of strings stuff would be 3. Test question, what is the type of variable length? Int. All right. Python, this is very Pythonic. It has the in operator, their in keyword. And so we can write Python code that reads like English. And we can say things like, if the string dog is in the list of string stuff, print found dog. Or in other words, if stuff contains dog, or if dog is in stuff, okay, all valid, right? Print found dog. Otherwise, right, else means otherwise, print no dog found. Because the string dog is in the list of string stuff, then found dog is what gets printed. Now, last week we learned about for loops, and for loops lend themselves really well to sequences. This is called a for each loop. And the way that we would read this, right, the way we know how to read this is for, and then there's like a variable, an invisible word each or every. So you can say for each item in the sequence of items stuff, print that item out. In this case, stuff is a list of strings. So we can now more accurately read this as for every string, let's call it item, right, stored in a variable called item, in the list of strings called stuff, print out that string called item. And then it will one at a time, right, on every new line, do dog, cat, boa, and it will repeat, right? If we had 5 things in this list of strings called stuff, suppose, then we would get 5 lines here. All right, we're going to many times start our code out, initialize a variable of type list to an empty list, just as kind of like a placeholder that we're going to put more stuff in later. And the way that we can do that is, we can do it with the constructor here. So what this is called a constructor, we can say numbers will now be a variable of type list, and we use these empty parentheses to say it's going to be empty list. The shorthand for that is because these square brackets make a list, we can just put nothing in them, and now this is basically saying numbers is now an empty list. Lists are mutatable. Lists are mutable. They are mutatable. They are changeable, meaning that we can do what we weren't able to do with a string, which is random item assignment or item assignment, right? So we can add a element or assign an element by index. Okay, we can add a slice of a list to another list. We can modify the middle of a list with another list or a slice of a list. We can delete from the beginning, the end, or anywhere in the middle randomly, right? We can randomly by index, okay? And we can also do that one at a time, or a slice from the middle, delete a slice, okay? What's that look like in code? Suppose we now have a variable of type list. So nums is a list of, in this case, ints or numbers, right? Ints, no decimal points. Okay, and it looks like this. And so now we can do what's called random item assignment. We can say, I want just this thing on the left-hand side. I want the number at index 0 to now be 46. So it was 12 before, and now I'm going right to left, right? So I'm saying take this value and put it into this index, put it into the spot at index 0. So make the list of numbers nums at index 0 equal to the value 46, right? And it's visualized like that. I can also say make the value at index 1, which was -3, now assign it a new value 324. All right, so this is the index position. So it's saying make the value at index 1 now 324. All right, just like we have methods of strings, like we had string.lower, string.upper, we also now have list has its own methods. So it's a different type of variable. So there are different methods or functions that we can call on a list. We're going to be using this one a lot, right? We can make an empty list and then append or add something to the end of a given list. We can remove by value or delete by index I. Anytime you see I here, this is referring to index. So I can say delete the value at index I from some list, whereas this one is remove the value specified by value from some list. We can also, and we'll be covering these in more detail next week, sort, reverse lists, very handy. If we have random data in from a network or a file, we can sort it alphabetically, numerically, okay? We can then reverse that sort. We can just take as given and reverse it, or sort it and then reverse it. Very powerful, very powerful. Count, just like with a string, we can count the number of values in some list. Find me the index at some index of a given value in this list. Insert this value at this index into this list. And then there's this one, pop. If you just say pop by itself, so this is a little bit confusing, but this notation here means it's optional. So it means that you can call it like this. You can just say pop, which will take the last item on the list and return it to you. All right. And then you can also optionally, that's what these square brackets notation in this case means, optionally specify an index to remove from the list and then also return you that value. And again, we're going to be covering all of these in more detail, all of these in more detail next week. But this week we're going to focus on append and remove. So append, just like it would read in English, appends some value to the end of the list. So if we had a list of numbers, a list of ints in this case, 3, 5, -12, it looks like this, and we wanted to append the value 40, it would go onto the end of the list over here. Okay. We can also remove some value from a list. So we had now numbers looks like this, 3, 5, -12, 45. And we want to remove 5. Well, 5's in here twice. Which one is it going to remove? The first occurrence. In other words, lowest index is another way of reading that. So it's gonna get rid of this guy. Okay, which would now leave us, right? This is what the list would look like after we remove this first 5, and we're left with 3, -12, 45. Then we could do the same thing again. We could call it again, and now it's going to get this last one at the end, and then this is what we're left with at the end. Okay. Well, what happens again? What happens if we call remove some value, but that value is not in the list now, right? There's no 5 in here now. Then that would be an error. And you're saying, hey, you're trying to remove some value, let's call it X, when that value, X, is not in the list. So we always want to do what's called a safe remove and check if the value is in the list. And we can actually do that, and we're going to have example code to show that. If value in list is true, then it's safe to remove it. And we're going to be doing that during our interactive lecture example.